Hello everyone, welcome to today's session. We are going to look at vectors. Please don't forget to subscribe and follow our YouTube channel for more updates. Now, looking at vectors, from our simple knowledge of physics, we have been introduced to what we call vector quantities. And vector quantities are known to be quantities with both magnitude and direction. Now, when I talk about magnitude, I mean the size. We mean the size, and then we also look at the direction. That means we must know where our vector is going. In order to term it as a vector, it must have magnitude or size, and then it must also have direction. Now, this brings us to our first assessment. We can have a line. That is called a line. But the moment we know that this line is coming from point A going to point B, so it is a line with ends A and B. So when we identify its direction, that is moving from A to B, then it will appear to have an arrow of its direction showing it is moving from A to B. And then from here, if we know the size of this line, then we can easily term it as a vector. Let us assume that the size of this line is given as a small a in the form of the vector of a tilde. That means that this is called a complete vector. We know its direction and we know its size. Once we know its direction and its size, we term it to be a vector or a vector quantity. So we continue, and at our level, we are going to look at the vector in its real scenario, looking at it under the two-dimensional geometry. For example, we are going to look at a vector having two components. That is the x component and the y component. This means that our vectors will appear in what we call the xy plane. They will appear in what we call the xy plane. For example, if this is x, this will be our y. So our vectors will be appearing in the y plane. So, since our vectors are appearing in that plane, what does this mean? If we try to analyze, it means that if we have a point here, we can have a 0 here, or our initial origin, the point O. And so we can have vectors moving from O going in the y direction, going in the x direction. So we can look at vectors appearing in such form. So, to term a vector as a vector, it must have an x and y component. And this takes us back that vectors can come out of coordinates. For example, if we have point P with coordinates 2, 3, it can be written in vector form as OP. OP in O is brought in indicating that it comes from the origin. Because by the time we read off a point, in this case, we've come from the origin. So it is OP, and this time it will be equivalent to, since we are turning this into vector form, it will be slanting, and it is going to be 2 and 3. So it stands, and now this is called a vector form. This is called a coordinate form. That is a simple insight of vectors. But we can continue and look at what happens to them. Do vectors add or subtract? Do they multiply? Do they divide? What do they do? For example, you see that vectors can be written while standing having components of x and y from coordinate form. They can be written in vector form. So the same vectors can be added or subtracted. So let us look at the addition and subtraction of vectors. Let us have a scenario. We have vector P, OP, given as x, y, and OQ given as x1, y1. So the moment we have values of OP like that and OQ like that, these vectors can be added or subtracted. For example, if we are to add, let us look at adding. It is OP plus OQ. If we are to add those ones, this means we are going to bring this vector which has xy plus this vector which has x1, y1. So we are going to add the 2. So this means that when we add OP plus OQ, this will give us, now we add components to components. We add x components together and the y components together. So this will give us x plus x1, then y plus y1, and that gives us a result in addition. The same idea or the same ideology is used in subtraction. Let us assume that we are subtracting, and it is vector OP minus vector OQ. When we are to subtract this one, it is xy minus x1 y1. So we simply see that OP minus OQ is going to be given as x minus x1, y minus y1, and this will give us the result in case we do subtract. That is a simple layout of how we add and subtract vectors. We can look at some examples here and then we see what comes next. We can have a simple examples. For example, given that OP is 2,8 and Q is 3,1, find Roman 1 OP plus OQ, Roman 2 is OP minus OQ. So that can be our simple question. We are given that OP is 2,8 and Q is 3,1. They want us to find OP plus OQ. But we don't have OQ in the question when we look at this. But we have coordinate Q. And I told you vectors come out of coordinates. So that means that from our Q, which is 3,1, we can find a vector which is OQ and is given as 3,1 in that form. So from here, we borrow the idea that we've been seeing and we can easily add these ones. So we say OP plus OQ is going to be equivalent to, what is the value of OP? It is 2,8, then plus the value of OQ, which is 3,1. And so when we add them, 2 plus 3, we get a 5. 8 plus a 1, we get a 9. So this is the result got after adding. And then when we look at Roman 2, looking at OP minus OQ, remember we already got our OQ, so we are going to just substitute and say this is the same as, what is the value of OP? OP is going to be 2,8, then minus the value of OQ, and it is 3,1. So we are going to subtract and say OP minus OQ is going to be 2 minus 3, which is minus 1, 8 minus 1, which is a 7. So this value gives us the answer in terms of subtracting. So whenever we are adding or subtracting, we only look at components with its corresponding values. So from this first session, we shall look at our simple exercise. We shall have some simple numbers to do, and then we shall continue with our next video. So we can say, given that P 2, 3, comma, Q is 4, 9, R is 0, 5, M is 4, negative 2. And then our questions are going to be very simple. Find Roman 1 OP plus OQ. Then Roman 2 is OL. Roman 2 is OL minus OM. Roman 3 is OP plus OM minus OL. So we can have these simple numbers for us to do